Hi everyone, it is Sri Devi from Department of Electronics and Communication Engineering, Dogini College of Engineering and Technology. In this video lecture, we are going to learn about two-ray ground reflection model. On completion of this model, the learners can able to understand the about two rays reflection model. The two-ray model considers both the direct path and the ground reflected propagated path. So two paths should be included, direct path and ground reflected path. That is why it is called as two-ray model. This is one of the model to calculate the path loss. So, consider the figure. In this figure, we are having a two-ray model. In this two-ray model, we are having ground path and reflected path. So here the signal is traveling on the way and meets on angle theta 1 and reflects with the theta I is the input angle, theta O is the output angle. So here E out is equal to input line of sight plus two-ray value. So two-ray model which consists of two overlapping waves at the receiver, one direct path and one reflected wave path on the ground. So the total received E field, that is E total, is the result of the direct line and the straight component ELO line of sight, that is direct line of sight, and the ground reflected component EG. So here HT is the height of the transmitter and HR is the height of the receiver. EO is the free space electric field in volt per meter at the reference distance decibel and from the transmitter, then D is greater than DO. The free space propagated energy field is E. E D comma T is represented as E D comma T is equal to E naught D naught divided by D cos MC into T minus theta where D greater than D naught. Is the envelope of the electric field in D meters from transmitter at any time here. So here the propagating waves can arrive the receiver at line of sight wave which is at the distance D. So at the distance D comma T equal to ER E naught divided by D into cos MC into T minus T by G. So this is the way to calculate the two-ray model, and the two-ray model here the system should consider the line of sight distance and its transmitted and reflected distance. So here the method of images which shows the way it is traveling and it is reflecting from the transmitter and receiver. So delta is a small variation from these two paths. Let us consider, and d double dash minus d dash should be taken, and it is calculated as the root of hr plus ht the whole square plus d square minus ht minus hr the whole square into d square, where hr and ht are the related transmitter and receiver heights. So here we can calculate the value of theta equal to 2 pi delta divided by lambda is the wavelength. It should be noted that the distance becomes large, and the difference between the distance d and d double dash becomes very small, and the amplitude of ELOS and EG are virtually identical. So referring to the phasor diagram of the figure, which shows how the direct and ground reflected rays combine and the electric field at the receiver at the distance of from the transmitter. So we can find this in the two-ray difference model. So the error is also calculated. The path loss is calculated in a two-ray model with an antenna gains can be expressed in dB as PL into dB equal to 40 log minus 10 log GT plus 10 log GR plus 20 log HT plus 20 log HR. This is the way to calculate the path loss. Path loss means it is the loss when the wave travels from one path to another path, that is called as path loss. So here we can understand what is the concept of two-ray model, and during that we can able to calculate what is the waveform transmitted through the line of sight height, and what is the waveform the wave travels through two-ray model. So this is all about two-ray communication model. Hope this session is useful to all. Thank you.